As you've heard, I am Bradley Hauer. I'm a senior PhD student here at the University of Alberta, Department of Computing Science. And today I will be talking about my work toward a concept-based theory of lexical semantics. So, as you have heard, this is a subset of my doctoral thesis research. The area that I'm interested in is computational lexical semantics. That's natural language processing involving specifically the meaning of words. So the study of meaning at the word level. So within artificial intelligence, we have natural language processing, which is the area of artificial intelligence that deals with human languages. Within natural language processing, we have lexical semantics. That's my area, where we specifically look at the meaning of words within human language. In particular, what I'm interested in are theory, resources, and multilinguality. So by theory, I mean coming up with clear definitions, assumptions, and best practices, not just definitions of key terms, but of the underlying phenomena, resources, and the tasks themselves that we use to evaluate AI models in lexical semantics. By resources, I'm talking about ways of representing and encoding knowledge that we use in our research, how we can construct them, how we can evaluate them, and how we can apply them. And in terms of multilinguality, I'm interested in looking at how we can leverage information from multiple different languages at once in order to gain novel insights and extract new information that is useful in lexical semantics. Now, the reason that I find lexical semantics so fascinating is because I see it basically as the ground floor of natural language understanding and ultimately artificial intelligence. If we want to design systems that can understand sentences, then we must first design systems that can understand the words within those sentences. And if we want to design systems that can understand discourses, documents, then we must be able to understand the sentences within those documents and so understand the words within those sentences. So it is my position that in order to reach a point where we can devise artificial intelligence systems that can understand natural language, right? NLU, that's natural language understanding, we must begin with lexical semantics. So I'll show some examples of the phenomena that we're working with here in lexical semantics. On this slide, you can see two English sentences in what field is his doctorate, and they emerged onto a vast field, and a French translation of each of those. Full disclosure, I do not actually speak French. These translations are automatically produced, so blame the system for any errors. Now, you can see here that both of these sentences contain the word field, but in each case, it's referring to some different meaning. The word field, we would say, is semantically ambiguous. You do not necessarily know what the meaning of the word field is without looking at some other source of information, because it can have multiple meanings. It can mean an area of study, as in the first sentence, or it can mean flat open ground, as in the sentence toward the bottom of your screen. And so there are two basic approaches that we might use to disambiguate this word. We might look at the context. We might look at the term doctorate and figure out that that is generally associated with one particular meaning of field. Or we might look at the translation. Even though these two meanings here are represented by the same word in English, they are represented, as you can see, by different words in French. So I've highlighted the lexical translation, the word level translation of each instance of field in the same color. So you can see that this ambiguity is something that really ceases to exist when we go from the monolingual context to a multilingual context. Now, one of the particular issues that makes multilinguality so important is the phenomena that I've observed that I call English first NLP, or English first semantics, more specifically. So this is an example from a paper that was published at the Language Resources and Evaluation Conference last year, Kisik-Shuren et al. You take the English sentence, "My brother is younger than me," and you run it through a contemporary machine translation system to try translate it into Japanese. And what you get is something that looks like this middle line right here. If you translate that back into English, void of any other context, according to this paper, the system might give you, my elder brother is younger than me. So this symbol here that I've highlighted, which is initially used to translate brother, can also be translated as elder brother back in English. So we end up, if we translate Japanese and back, we end up with this completely nonsensical sentence, my elder brother is younger than me. So it's a self-contradicting result. Modern translation systems, ChatGPT does this, Google Translate, I've observed doing this, making these kinds of mistakes where instead of trying to translate the underlying concept, the underlying meaning, what the system is actually translating is it's just looking for a translation for the word without actually literally preserving the underlying meaning. And so I think that lexical semantics and multilingual lexical semantics in general is particularly important to resolve issues like these. And so that leads me to this idea of why we need a theory. Why do we need definitions? Why do we need best practices? Why do we need criteria for the correctness, for our tasks, for our resources in order to make progress in lexical semantics? And there's two papers here that I want to quote from, both published just this past summer. So the first is Tedeschi et al., 2023. Apologies for any names that I mispronounced. In recent years, research in NLP has been driven by a frantic race to reach the top spot in popular benchmarks. So what they mean by that is the typical NLP paper these days will take some task or set of tasks, identify some standard benchmark data set for that task, and simply do whatever it takes to get state of the art, chasing after the state of the art, just to get higher accuracy, higher F1 score, higher whatever metric happens to be used for that particular task. And the question this paper raises is, what does this level of performance really mean? If we're just going to higher and higher levels of performance, whatever it takes, how can we really evaluate how well the models are doing? What the underlying theory of these problems is? On a similar note, Nityasia et al., 2023, coined the term scientific debt to point out how natural language processing has sacrificed scientific understanding for increasingly higher performance. I argue that in the age of large language models, such as ChatGPT, predictability and interpretability are more important than ever. And for that, I believe that we need clear definitions of our resources, of our tasks, and of the underlying phenomena that we are dealing with. And we need, having laid that strong theoretical foundation, to build our methods on top of that foundation so that our methods will be interpretable and predictable. As I mentioned, this presentation does cover a subset of my thesis research. So I do just want to, in the spirit of that, briefly cover my thesis statement. It's a bit lengthy, but I'll go through it step by step. My statement is as follows. An empirically validated theory of sense, synonymy, translation, and lexical concepts yields an improved understanding of lexical resources, methods, and tasks. And that will give us novel evidence for linguistic hypotheses and allow us to build a taxonomy of semantic tasks. So starting from building that solid theoretical foundation, clear definitions, best practices, and assumptions, we're going to be able to improve our understanding of the field and use that to derive some new methods that we will demonstrate have empirical value. So now on to the outline of the main part of this presentation. It'll be in two parts. The first part, I will go through this theory of lexical semantics, analyzing and formalizing various intuitions about key phenomena. I'll give clear definitions and axioms for this for these issues. And I'll demonstrate that by building a method on top of this theoretical foundation, we can create novel multilingual resources that outperform prior work in that area. In the second part, I will shift my focus from resources and key phenomena to the problems themselves, the problems that we use as our measuring stick to evaluate the performance of methods in lexical semantics, such as language models. I'll argue for a taxonomy that shows the relative hardness of 13 tasks, arguing from reducibility and equivalence, borrowing those terms from theoretical computer science. I'll argue that there exists a set of wordnet complete problems that are the hardest problems within that taxonomy, and I will again provide an empirical validation. So with that, let us move on to the first part, proposing and testing a theory of sense, synonymy, and translation. So let's begin. Now, no discussion of lexical semantics would be complete without a discussion of the Princeton Wordnet, or PWN. So you can see here just some screen grabs from Google Scholar. The earliest paper on WordNet has been cited more than 7,500 times. A book on WordNet, published by Christian Feldbaum in 1998, has received nearly 18,000 citations. And one of the key papers, briefly describing what WordNet is closing in on 20,000 citations. So it should be clear from that the influence that the Princeton Wordnet has had on the field of lexical semantics. So what is this resource? So WordNet consists of synsets. The basic building block of WordNet is synsets, such as this. So we've got a set containing field and subject, another synset containing field and plain. Each of these synsets contains some words that have a shared meaning that they can express. So for example, the field and subject, they can each express the area of study sense of field, whereas the field and plain can both express the sense of flat, open ground. In WordNet, each of these synonym sets, that's what synset is a contraction of synonym set, is a gloss, so a description of the meaning that the words in that synset can express, as well as optionally one or more examples showing how that meaning can be expressed in practice. Not all synsets have examples, but many do. WordNet was manually created by experts. In fact, it was not originally created for lexical semantics at all. Rather, it was created to test hypotheses in psycholinguistics. However, it quickly found use in lexical semantics and natural language processing more broadly as a lexical database, that is a database of word meaning that is readable both by humans and machines. So you can see here that the information in WordNet, the synsets, the glosses, can be viewed and understood by human readers. However, the files are structured in such a way and contain some additional rich information that I have not shown on this slide that makes it ideal for using and implementing in semantic applications. So it's widely used as a sense inventory for semantic tasks. It gives us a discrete set of senses for each word. And it also allows us, when used as a sense inventory, to map words in context to these discrete knowledge-rich synsets. It's also proven to be a vital source of knowledge for semantic methods. In many cases, particularly in the 2000s and 2010s, WordNet saw extensive use as a substitute for labeled training data in tasks for which either no training data was available or very little training data was available. WordNet itself would actually be used as a supplementary source of knowledge to allow the methods to function. Now, the key issue with the Princeton Wordnet is that it is monolingual. And I've discussed earlier in this talk the importance, as I see it, of multilinguality, going from monolingual to multilingual. So BabelNet is an example of a project that seeks to expand the Princeton Wordnet from an English-only resource to a multilingual resource. So you can see here a French word and a Chinese word have been added to each of these synsets. So it's no longer just conveying meaning about English lexical semantics, but it's linking these meanings to words in other languages as well. And so BabelNet has found widespread use throughout multilingual lexical semantics, in recent years becoming a standard multilingual sense inventory. And applications like this have given rise to the task of WordNet construction. The building WordNets like this for specific languages or sets of languages is an area of research in itself because these resources are so useful. That includes attempts to expand WordNets like this. BabelNet is one example, open multilingual WordNet, universal WordNet, we'll see that later. Processes to try and expand either automatically, manually, or some combination of the two. In addition, there's also been attempts such as the Euro WordNet project to build resources like this from scratch for other languages. So just as Princeton Wordnet was built for English, there were attempts to build wordnets manually or semi-manually for other languages as well. Now, in the 2020s, there is a very big open question about lexical semantics, which is, do we really need these discrete word senses at all? When I say discrete, I'm talking about discrete as opposed to continuous. Do we need to have an explicit representation of word senses? After all, as far as we know, services such as ChatGPT, Google Translate, other large language models, as far as we know, they don't use discrete word senses. Instead, they have an internal and continuous view of meaning. So a large language model, given a sentence that they emerged onto a vast field, might take a field in context and generate a contextualized embedding, such as this vector embedding that we see here. And then that could, through some process, be mapped onto a concept, some representation of the concept. Now, I argue that this continuous view is not sufficient for lexical semantics. I believe that word senses are real, that there are discrete word senses, and that they matter. I believe that they are important for explainable outcomes. So to be able to explain how it is that field was mapped to this vector, and then this vector was mapped to this concept, that is an area of study in itself. Whereas if we were to tag this word in context with the corresponding wordnet sense, that is something that is far more explainable, that is tied directly to a static, stable resource that, again, is fully human readable. Linking text to resources can also be useful to take advantage of the rich information that resources such as WordNet encode. And it can also be useful for evaluating models. If I were to ask a language model to, say, decode this embedding into a definition, tell me the definition of field in this context, it might be difficult to evaluate how correct it is. What exactly constitutes a correct definition of a word in context? Whereas if I define my task in terms of mapping a word in context to a specific sense, then it becomes more feasible to identify a correct or incorrect response. And so based on that, I argue that we need a theory of word nets. We need a theoretical basis to describe what a word net is and how it ought to be constructed and what properties it ought to have. And this is an open gap in the literature. For example, in 2018, 5 years ago, Stephen Neal argued in a position paper that there are few agreed principles or common guidelines for evaluating extracted synsets. So he's talking here, extracted synsets, about automatically generated synsets, automatically generating, for example, French synsets or Chinese synsets, perhaps given the English ones. He goes on to say that it is often difficult to decide what constitutes a correctly or incorrectly extracted synset, and that a set of agreed principles will be an important next step in construction and extension of wordnets. Definitions of key terms in WordNet are often unclear, ambiguous, or flawed. And overall, it is unclear exactly what properties a WordNet should have. What is considered correct or incorrect when we are constructing one of these useful resources. And so that is the critical gap that I intend to fill in this part of the presentation. So the way I'm going to do that is I'm going to define WordNets and everything in them in terms of concepts, discrete units of meaning that can be represented in a lexicon, entries in a dictionary, let's say. So a sense then is going to be defined as a pair of a word and a concept. For the pairing of the English noun field to this concept, flat open ground, that's going to be a sense, a pair of a word with a concept. And the sender axiom, one of our fundamental assumptions, is that every word in context has exactly one sense. Anytime we see the word field mentioned in a sentence, it is referring to some specific concept. Synonyms are words that express the same concept in some context. So field and plain are synonyms because there is a concept, namely flat open ground concept that we see, that express the same concept. They both express that concept, so they are synonyms. Now, translational equivalents are, under this theory, cross-lingual synonyms. So this Chinese word and this French word would be synonyms. And this is actually extracted from Babelnet, which I mentioned earlier. And so this resolves actually a long-standing disagreement in lexical semantics as to how exactly translational equivalence relates to synonymy. Is there such a thing as cross-lingual synonymy? Is it something distinct? The position that I'm taking here by laying out this theory is that synonymy and translational equivalence are really just two sides of the same coin, the relation of sameness of meaning, whether within or across languages. A synset, then, is the set of words that can express a given concept. So rather than defining a synset by a particular gloss or an image, or just a set of words, we're going to insist that there be a one-to-one relationship between concepts, things that we can express in words, and synsets. So the result of that is that words should share a synset if and only if they are synonyms. So the key point here is that synsets are indivisible. If we were to take, say, plain out of this and just put it in its own set somewhere else, that would be incorrect under this theory, because then we would have two distinct synsets corresponding to a single concept. And so the point that I'm making with this part of the theory is that that is explicitly disallowed, that there must be one synset of concept. Now, a result of this theory, something that we can derive, and in our paper actually prove, what we call the bitext theory. So that says that if words are aligned in sentence translation, as for example, the English word brother and the French word frère are here, if they are aligned, and if they are synonyms, then they must express the same concept. In other words, in plain English, if it is possible for aligned words to express the same concept, then they do. Now, this is not necessarily given. It may be the case, as we saw in the Japanese example earlier on in this talk, that a word is not translated literally, either because no suitable word exists, or because a suitable word is uncommon, or because of a variety of other reasons. But what we're going to say is that if it's possible for the aligned words to express the same concept, then they must. Now, how can we test this? I've laid out a theory, I've laid out definitions, but of course, we want to verify that this theory is actually correct, that it actually maps onto what we observe in reality. And the way that we validate this theory is by applying it. So the theory provides us with best practices, guiding us toward an implementation. So the task is the task of WordNet expansion, which I talked about earlier. Given a Princeton Wordnet synset, which is English only English words, we want to add a French sense to it. And we are given only what we need in order to use the bitext theory. An English-French dictionary, so for every English word, we have all of its synonyms listed in no particular order, and a translation model that allows us to translate English to French. And so what we're trying to do here is to apply our theory to turn a strictly monolingual resource, such as WordNet, into a multilingual resource. The method looks something like this. I'm sure you're all getting tired of seeing those field synsets, so I've switched to a new example. Let's consider the synset containing awning, sunshade, and sunblind. This one has the synset has the gloss, a canopy made of canvas to shelter people or things from rain or sun. We turn that gloss into an example. Remember, not every synset has an example usage, and not all the examples that are there are useful. Some of the examples are not that good. So we create our own example by just using this template. In this context, the noun sunshade means a canopy made of canvas, so on. We then translate that into French, and we can see that sunshade in our example is aligned in the translation with this French word, parasol. We then check, we want to make sure that this is a literal translation, that the underlying concept has been translated, and it's not, as was the case with the elder brother example we saw earlier, and the check passes. This pair of words is indeed in our dictionary. There are synonyms. So, under the theory that I've laid out, it is reasonable to add this French word to this synset, thereby taking this from a monolingual resource to a multilingual resource. So how well does this work in practice? Well, by comparing to the Universal WordNet, which was another project to automatically expand a monolingual WordNet to a multilingual one, it worked 70% of the senses it produced were actually correct under our evaluation framework. Whereas our bilingual dictionary net method, or BiDic-net, achieves a precision that is about 10% higher, in the high 70s. The Universal WordNet obtains a coverage of about 30%. So for about 30% of the sense that it is given, it is actually able to find and correct sense. Whereas with our method, we can improve that to about 40%. And the key takeaway here is that the Universal WordNet is much heavier in terms of the assumptions that it makes. It assumes the method is significantly more complicated than what I laid out. It's a sophisticated graph-based probabilistic method. And it depends on various other resources, including pre-existing multilingual wordnets. So with our method, which is based on the theory that I laid out, we can actually end up getting more and better with less. So with that, I can wrap up the first part of this talk. I've laid out a first of its kind theory of wordnets and the associated phenomena, establishing a set of best practices for wordnet construction, and have demonstrated that this theory-driven method achieves better results. I argue that it is more explainable and interpretable due to its simplicity and its minimality of resource assumptions. And I've shown that with this theory, by starting from the solid theoretical foundations, we can create or improve useful resources. With that, we are ready to move on to part 2, in which I will present my work toward a taxonomy of problems in lexical semantics. So this is based on some fairly freshly published research. It's an amalgamation of 2 papers, one that was published last summer, 2022, and one that was published just a couple of months ago in July. So in this part of the talk, I'm going to be shifting my focus from resources and the phenomena that they are meant to model to the problems themselves, the problems that we use to benchmark and analyze the language models. Problems in lexical semantics, as I have said, are related to judgments about word meaning. But alongside the problems in lexical semantics, we must also discuss the problems with lexical semantics. So tasks in lexical semantics are often quite poorly defined in practice. Moreover, even where they are defined, or the definition can be inferred, the relation between these tasks is unknown. It's an open question whether some of these tasks are more difficult, whether some of them might be equivalent to one another. And this makes interpreting results more difficult because the tasks may not be independent. So if we devise a new language model that is able to get the state of the art on, let's say, task A and task B, if task A and task B are equivalent to one another, that is, if they are just different ways of testing the same thing, then state-of-the-art results on A and B are not necessarily more impressive than state-of-the-art results on one of those tasks alone. So it's important that we analyze how these tasks relate to one another so that we know how best to interpret results across multiple tasks. Now, no discussion of tasks in lexical semantics would be complete without a discussion of word sense disambiguation, so known as WSD. This has long been the flagship task of lexical semantics. It is among the oldest and I would say certainly the most well-studied. In this task, a system is given a word in context and a sense in meaning, such as wordnet, and must select the correct sense. So, given the sentence, semantics is a fascinating field, we want to automatically decide, is field here referring to an area of study, or is it referring to what is the meaning of field in this context? Another task, more recently proposed, is target sense verification. This is framing word sense disambiguation as a binary classification task, what in theoretical computing science would be called a decision problem. So we are given a word in context and a single sense, And we were asked, is this the correct sense? Does field in this context indeed refer to an area of study? And so an automated system for target sense verification would have to tell us that, yes, this is indeed the correct sense. More recently proposed is the word in context test. So this is relatively new, but it has garnered a lot of attention in lexical semantics. Here we are given a word in two distinct contexts, and we must determine whether or not they have the same meaning. So semantics is a fascinating field. The team walked onto the field. We want to evaluate whether the meaning is the same. And so a word in context system, we would want it to tell us automatically that no, these are not the same. They do not mean the same thing. Now, the issue here is that the first two tasks, word sense disambiguation and target sense verification, are defined in terms of senses, whereas word in context is defined in terms of meaning. So it's not clear how we can analyze the relation between those two tasks when they are related to two distinct phenomena. One is sense, one is meaning. Now, in part one, we already linked senses to this idea of concept. We say a sense is a pair of a word and a concept. So now what we're going to do is try to do the same thing to meaning. We're going to put forward the hypothesis, what we call the concept meaning hypothesis, that words have the same meaning, which is relevant for the WIC task, word in context, if and only if they have the same concepts. And so we will define word sense disambiguation, target sense verification, word in context with, and 10 other tasks in terms of concepts. And so grounding the tasks in concepts is going to facilitate reductions in analysis. So here's what this would look like. So instead of saying WSD is going to give us a sense, we say that it's going to give us a concept. We want our system to identify a concept and provide that to us. Target sense verification, again, our input is going to be a word in context and a concept. Is this the concept that this word expresses? And finally, for word in context, with, as I said, given two words, or rather two instances of a word W in contexts CX and CY, we want to decide whether they express the same concept in each of those. So we're redefining these problems in terms of concepts to facilitate our analysis. And under our hypothesis, that should not impact how it relates to real-world data sets. Why is this useful? Well, let's suppose that we have this WIC instance that emerged onto a vast open field. You belong to the field is you. We don't have a way of solving it. Let's just suppose we don't have a WIC system. But we do have a system for solving WSD. Well, what we can do is we can have our WSD system tell us the concepts, the concept field expresses in each of these examples, and then just compare them after the fact. So if we have a WSD system, we have a machine that solves WSD, we can use that to build a machine that solves WIC. And in fact, we can do this pairwise with each of the other problems that I mentioned. So if we're just going over this briefly, if we want to solve WSD, but all we have is a machine that solves TSV instances, well, we can just iterate over the possible senses. One of the advantages of having a predefined fixed sense inventory that's finite is we can just say, is sense one the correct sense, sense two the correct sense, and so on, and get our output back. Of course, that assumes we have a way to solve TSV. So it turns out that if we have a machine that solves WIC, we can build a machine that solves TSV instances by converting the input sense into an example sentence and just applying WIC to the input context and the example sense and taking the classification that it produces. So given a machine that solves any of these three problems, a WSD system, a TSV system, or a WIC system, we can construct methods to solve the other two. So this is the advantage of grounding everything in concepts, defining everything in terms of concepts, because we can use that to argue for these reductions here. Now, there are many more tasks in lexical semantics that we can analyze. For example, in WIC, why is it that it must be the same word in each context? Why field and field? Why not two different ones? And so we'll generalize WIC to multi-WIC, and we can say that the words WX, WY which may not even be in the same language. These may be one word in English and another in French. Do they express the same concept in their respective contexts? We can also constrain W sub X and W sub Y to be in the same language. We call that monolingual WIC or mono-WIC. Or we can constrain them to be in different languages. So about 2 years ago at the Semiball workshop, there was actually a competition that our NLP group participated in that addressed this very task, where we were solving WIC instances where the two instances were in different languages. So this is something that we encounter in practice in real world data sets. Now, the lexical substitution task, this is one that is notorious, difficult to define. So in colloquial terms, we're asking, can one word replace another in context? That's a very difficult idea to nail down. It's extremely vague in practice. So we need a more precise definition. And this idea of grounding everything in concepts, it provides that. We say that word W sub Y can substitute to W sub X in a context C if they express the same content of the same concept in that context. And just as with the word in context problem and its variants, we can define a monolingual variant or cross-lingual variant of this problem. Now there's also the synonymy problem. Given two words, void of any context at all, are they synonyms or not? And this is important because this is a task that would allow us to construct in a monolingual setting a thesaurus, and in a multilingual setting, cross-lingual setting, a bilingual dictionary. Remember, we used a bilingual dictionary earlier for our bilingual dictionary net method. So this is a particularly important problem, and we can define its multilingual format. Words W sub X and W sub Y may be in the same or different language. This is true if they express the same concept in some contexts. And again, we have analogous variants for cross-lingual, where the words are constrained to be in different languages or the same, and monolingual variants as well. And the final problem that we'll look at before we move on to the taxonomy, putting this all together, is the sense problem. So you'll recall that in part one, I defined a sense as a pairing of a word with a concept. Now, obviously, not every word can express every concept. So it might be useful to ask, for example, if we are constructing a word net, can this word express this concept? Given a word and a concept, does that sense actually exist in the lexicon? So with that, I've introduced 13 problems in lexical semantics, and you can see here the layout of all of them. We can see the synonymy problems, the lexical substitution problems, the word and context problems, as well as WSD, target sense verification, and the sense problem. And you can see that for some of them we have cross-lingual, multilingual, and monolingual variants. Now, I've already argued that these three problems are equivalent to one another, shown by these bidirectional arrows. They are equivalent in difficulty. If we can solve one, we can solve any of them. It is also the case that some of these problems are actually special cases. For example, the monolingual synonymy problem, given two words in the same language, are they synonyms or not, is actually a special case of the multilingual synonymy problem. So if we can solve multilingual synonymy, surely we can solve the monolingual version as well. So these arrows there are implied by that, and that's showing that we can reduce monolingual synonymy to multilingual synonymy. We can use the latter to solve the former. And finally, to complete this picture, we'll add in some more reductions. So these are reductions that we derive from the concept-based definitions that I've laid out in the previous slides. So the overall idea here is much the same as what we did with TSV, WST, and WIC. We show that given a problem or given a machine that solves one, we can build a machine that solves the other, thereby showing that, for example, multilingual lexical substitution and multilingual WIC are actually reducible to one another. So given a system for solving one, we can solve the other. Now, the key point here that I want to draw attention to is these 6 problems within this dashed box right there. Those problems, you can see, are all equivalent to one another. If we have a system that can solve any of them, then we can actually solve any problem in this taxonomy just by following the arrows. For example, If I have a system that solves multilingual width, then I can solve the TSV problem by reducing it to WSD and then to multilingual width. And I can solve cross-lingual synonymy by reducing it first to multilingual synonymy, which is in the special case of reducing that to multilingual lexical substitution and reducing that to multilingual width. So these 6 problems here, what I call the WordNet complete problems, are by reduction demonstrated to be the hardest problems in this taxonomy. So this gives us an idea of the problems that we want to target. It also gives us the idea that it would be sufficient to solve one of these in order to essentially demonstrate that we have an understanding of the underlying phenomena for each of these. Now, of course, we want to validate this finding by experiments. Again, it's one thing to lay out a theory, it is another to confirm that it works in practice. So what we did is we took a sample of 5 of these reductions: WIC to WSD, WSD to WIC, multi-WIC to WIC, multi-WIC to WSD, and multilingual lexical substitution to WSD. For each of these, for the source problem, the first one, we found an actual data set, usually one derived from an international competition held at a workshop. For example, semi-vol data sets, that's one that was fairly widely used. And we took an off-the-shelf system for the latter test, the second test. So for example, to test the WIC to WSD reduction, we had a set of WIC instances, a word in context data set, and we found a WSD system that was performed fairly well. And by implementing our reduction, we used the WSD system to solve the word in context instances. What we found is that the performance of these reductions generally meets or exceeds expectations based on the accuracy of the systems and the quality of the resources that we are working with. So generally, the theory upon which the reductions are based seems to hold in practice. These concept-based reductions seem to be a pretty good model of how these problems work in practice. We did some manual error analysis, and we found that errors were, in general, due to errors made by the systems and resources, not actual exceptions in our hypothesis. So, for example, if we try reducing a word sense disambiguation instance to a word in context instance, it gives us the wrong answer. What we found in practice is that was because the word in context system made error, not because there was some underlying flaw in it. So with that, I am ready to wrap up this presentation. So we'll have plenty of time for questions. I have presented a theory of sense, synonymy, and translation that allows us to derive a set of best practices for WordNet construction and analysis of problems in lexical semantics. I have presented a first of its kind taxonomy of semantic problems. I've validated my theoretical findings with experiments and confirmed that in real-world data sets, this theory actually holds up. And I hope that I've persuaded all of you that despite recent advances in language models, what they can do, what kind of results they get, that theory is still relevant in lexical semantics. And that despite its long and venerable history, the field of lexical semantics is very much far from solved, and that there is still much more to be learned. Thank you for your time. I look forward to taking any questions. Yes.
I remember you have a slide saying same meaning equals same concept, right? So what's the difference between meaning and sense? Same meaning equals same sense. So what is the difference between meaning and sense?
Sure. So meaning, what we're talking about with meaning is human judgment. So when you look at the WIC problem, you ask a human annotator, do these words have the same meaning? So meaning is a comparison between words in context. What sense is it's a discrete entry in a particular sense inventory. So for example, wordnet is an example, it gives us senses. And so the hypothesis there is let me take the other direction. We could easily imagine that for a particular sense inventory, perhaps meaning and sense don't align. It could be, in theory, that human judgments of meaning do not agree with a particular sense inventory. Maybe that words have the same sense, but human annotators say that they don't have the same meaning. So the hypothesis is that this will not be the case in practice, that human judgments about meaning, even if they are naive to the actual sense inventory, will tend to align with that wordnet sense inventory.
So you mean sense is relative to a sense?
Yes, senses do come from a sense inventory.
Okay, so
However,
what if we accidentally deleted wordnet, then you mean there's no senses at all?
no, I would argue that the senses still exist. WordNet is just providing us a record of them.
Okay.
So WordNet is, I laid out a theory and I defined sense as being a pairing of a word with a concept. And so the senses exist, and WordNet is an imperfect implementation of a theoretical model.
Okay.
The WordNet can and does have mistakes. There are errors in WordNet. I found a few in my time working with it. So it's not the case that, but for WordNet, these senses do not exist. Rather, my position is that the senses do exist, and WordNet is how we represent it. Yes.
Yeah, how if like the whole sentence is ambiguous? Like, for example, like the chicken is ready to eat. Like it can have two meaning, whether like the chicken is cooked and we can eat it, or the chicken itself ready to eat.
Excellent question. So this goes to the sender axiom that I discussed earlier. So when I was laying out the theory, one of the fundamental assumptions is that for every word that expresses a concept, there is a specific sense that the speaker or writer had in mind. So if I say the chicken is ready to eat, using the example you gave, presumably I would have something in mind. If I'm telling you that, then I have one of those two meanings that you laid out in mind. Now, it may be that there's not enough information for you to figure that out from the context. It may be that, a misunderstanding could happen because I haven't given you enough context, but that doesn't change the fact that there still is an intended meaning that I have in mind, and that is the underlying sense of that word in context. Does that answer your question?
Yeah.
Fantastic. Other questions?
But in the given example, each word has one and only one meaning, so I don't think it can be seen as a semantic ambiguous
Can you repeat the question, please?
case, because it's syntactically ambiguous, right?
So-
Who is?
So I think what you're inquiring about is the case of semantic versus syntactic ambiguity. So the classic example of this, and I'll just repeat this, I think some people didn't get the
Can you
question.
repeat the question? Yeah, I cannot hear.
Okay,
Thank you.
so the question, as I understand it, is how can there be a single fixed meaning if there are multiple ways to parse the sentence, if there are multiple ways of inferring the syntax of the sentence? Have I summarized your question correctly? Fantastic. So the answer to that is that there is semantic ambiguity and syntactic ambiguity. So a classic example of syntactic ambiguity would be, I saw a man with glasses. Did I use my glasses to see the man, or was the man wearing the glasses? So again, what I would postulate there is that because the sender axiom implies that there is a particular meaning that I have in mind. So when I say saw a man with glasses, I have some specific meaning in mind for each of those words. I would argue that it would follow that the sentence also has some specific meaning as well. So the sentence has, there's some intended parse of that sentence, some intended syntactic structure. And just as every word has a sense, it would follow that every sentence has a syntactic structure to it. So again, even if the context is not sufficient to disambiguate the syntax is still there. It's in the intention of the speaker or the writer. Does that answer your question? Fantastic. Other questions? Also, I can't see the chat here. So if there's a question in the chat.
I've been watching the chat.
Fantastic.
There's no questions.
Fantastic. Yes.
So you said lexical semantics far from solved. So what is the ideal case, the ultimate goal of the research on lexical semantics? So ideally, suppose all the research obstacles are solved, but what are the obstacles? What should we achieve?
Well, what I would argue, based on the taxonomy I laid out, that the ideal would be to have a wordnet that is as correct and complete as we can possibly make it. When I say a wordnet, I mean something multilingual. So something that conforms through our theory to the greatest extent possible, and that has as many senses as I can. And then, with respect to that sense inventory, to be able to identify the sense of any word in context. So I've argued that word sense disambiguation is one of the keystone tasks. So the ideal dream of lexical semantics would be to have that word net, that complete sense inventory, and with that, to be able to solve word sense disambiguation. And that, again, under this theory, would allow us to essentially solve any of these problems in lexical semantics.
So the main obstacle will be the incompleteness of the sense inventory for the dictionary, lexical dictionary.
So there are two obstacles to that. One is the incompleteness of word nets, which I think could only be resolved by coming up, just due to the volume of the data, with a method for automatically crafting these word nets. So given a huge amount of data, given the internet, build a word net. So that's the first thing we need, is an automated method of constructing multilingual word nets from data. The second thing that we would need is essentially a word sense disambiguation system that is as good as it can be given the context it is given. So state-of-the-art WSD systems still have trouble on rare senses. They're quite good at detecting the usage of frequent senses, but if you use a sense that is rare or unusual, modern WSD systems, even ones based on state-of-the-art language models, they do tend to struggle with that. So those are the two obstacles I see. One is a resource problem, and one is a system problem. Yes.
Yeah, so I love what you presented, the way you presented it. So just I guess the most obvious limitation or choice that you made was this: it's very discrete, right? Like the meanings concepts are very discrete. And I think you alluded to this with the word alignment. But I was thinking about that. The existence of synonyms in English anyway is you could see it as, you know, there are taxable taxonomies. Two words, like a speaker or a writer will use one word versus the other to achieve a slightly different outcome. So you could say that I'm confused by all this, right? But a lot of the meaning or concept that's referred to by, say, the word field and the word discipline are the same. If you say he was the best in his field, he was the best in his discipline, you know, those two things feel a little different. They kind of allude to different shades of meaning.
Sure. So I think what you're driving at here is there may be factors that affect our word choice other than just the dictionary definitions. Things like register, some terms are considered more formal than others. So you're absolutely correct in that there are other things that guide word choice. However, I would argue that those don't actually affect the underlying concept that is expressed. So I used throughout this presentation pictures of a field in an attempt to represent the abstract concept of field. I would argue that synonyms do exist in English, and I would argue that synonyms exist in all natural languages because there are multiple words that we can use to refer to the same concept. And there are phenomena that happen, such as borrowing between languages. So, for example, a lot of words in English might be borrowed from French or from other languages that would result in there being multiple words for a particular concept. Another thing that I would say to that is, even if I grant you, in theory, that there is no synonymy within a language, surely there must be synonymy across languages. Otherwise, translation would be impossible. So even if you exclude monolingual synonymy, these synsets still would not be singletons in the multilingual context.
I'm not arguing that, roughly speaking, just that you seem to make a really clean cut. So if you have, 99% overlap of the meaning of one word versus another, there's still that 1%, which users of the language use expressively. So at some point you could say, well, there's different level of formality or different emphasis, whatever. At some point, are you going to have to call that meaning? an aspect of meaning. And you know, I'm not challenging the entire framework. I'm just wondering how you soften it, how you kind of make it a little more malleable and continuous. Or do you really think that this is so far, what I'm talking about is so much in the detail, and negligible, that this approximation is actually good?
I don't think it's details at all. I think it's actually a very relevant question, and it gets to the key word is lexicography, the explicit writing down of a lexicon. So, for example, how we write dictionaries. How do we decide how many different meanings a word has? You know, are these two meanings distinct? So there absolutely is room there, I think, to argue, is this really a distinct meaning or isn't it? The position that I'm taking is that there is an underlying answer. A translation is either seen as correct by someone who is, let's say, a native speaker of the target language, or it's incorrect. So there is, I would say there is an underlying fact, and that any resource we produce, whether it's a dictionary, a wordnet, anything else, is only ever going to be an approximation of the theoretical ideal because of those very difficult corner cases, such as what you've said, and those factors such as register, formality, and so on. Does that answer your question?
Yeah, it's just, I mean, you have human graders as the input, it's never gonna.
Oh, of course,
Exactly.
of course. Humans will
It's
never.
also not gonna be stable over time,
Oh, of course.
consistent across people.
I saw a question at the back of the room. Yes.
Following on this idea, is it possible to have an objective measure that doesn't involve human raters? For example, speech acts. I say, I want you to go to room 7 and think about an object. And the person who has the object or doesn't can evaluate whether I have the right interpretation. Is that possible?
That's tricky because language is defined by how humans use it. You know, a natural language is how people communicate.
Well, a computer program, that
Yeah.
language is defined by an action. Hey,
Yeah.
it's possible to be objective.
Is it possible to be objective outside of human evaluation?
Like a speech acts right there.
I'm not sure it is. I'm not sure how you could get a ground truth without a speaker of the language involved at some point. I think there would have to be a speaker of the language in the loop at some point to give you some reference point to compare to. But that's a good question. I'll have to think about that a bit more.
Give me a talk next week about.
I'll be there. Yes.
Even in the work.
Sorry. So, I believe on slide number 20, you mentioned the belt text theory. Yes, so this one, so you mentioned this if and only if condition that, I mean, those two words must be appear at the same position. And besides, they have this similar meaning, right? So I'm wondering, have you taken the grammar aspects into consideration? For example, in some of the languages, I believe in French and English, they're grammarly speaking, they're similar. But for example, in Japanese, they put verbs at the end of the sentence, right? So the sequence is different.
Yes, excellent question. So this goes through alignment. So it is actually the case in French that typically in English adjectives come before words. In French, adjectives typically come after. So if that was the case, let's say if this was a language where the subject came at the end of the sentence, then the alignment link would just look like this. It doesn't have to be the same position. It doesn't have to be monotonic left to right. So the idea of an alignment system is that it will give us this link even across word ordering. So the problem of alignment actually solves that issue, even if there is word reordering. So that's something we solve with alignment. Does that answer your question?
Yeah.
Thank you so much.